At first glance, circle equations look simple, just another formula in coordinate geometry. But when you dive into A-level past papers, you realize how creatively these questions can twist the same idea. In this video, we'll explore how to handle every style, from finding equations to tangents, intersections, and hidden geometry within circles. Let's get started. So this first one is question 8 from Summer 25-1-1, and this is a big question. It has got 8 marks. The circle with the equation x squared plus y squared minus 6x plus 10y minus 27 equals to 0 intersects the line x equals to minus 2. Now observe, this is not the standard equation of circle, it's the expanded equation of the circle. Okay, so first task, I need to get these intersection points P and Q. So I've got a line, I've got a circle. Let's substitute x equals to minus 2. So if you substitute minus 2 in place of x, this will look like y squared minus 6 times minus 2 plus 10 times y minus 27 equals to 0. So it'll become 4 plus y squared plus 12 plus 10y minus 27 equals to 0. You can always pause the video and do these calculations yourself. Just stay connected because, the best way to practice is just do the solution yourself and you can always check my work later. 16, and this is going to be 16 and 4, 7, 11 minus 11 equals to 0. Let's, you can use the formula as well, but you can just do the middle term break as well. 11y minus 11 equals to 0. So let's factorize this. One of them is going to be y plus 11, and the other one is going to be y minus 1 equals to 0. So y is either negative 11 or y is a positive 1. So my coordinates are minus 2, minus 11, or minus 2, positive 1. Any one of them can be a P or a Q. It doesn't matter. So these are P and Q. Now they're saying that find the area of the triangle formed by the tangents to the circle at P and Q and the line x equals to minus 2. Okay. So I've got a circle. Let's just sketch a circle. And I hope you know how to quickly judge the coordinates of center using the expanded form. If you do not know, what you can do, you can go for the completing the square. And I hope you've learned that in your quadratics unit, you can do the completing the square, write it in standard form, and then you can, write the center and the radius. But I just need the coordinates of the center, so I'm going to be applying the shortcut method, which is, so the center is a minus g and a minus f. And what is g? G is half of the coefficient of x, minus 6 divided 2. That's a negative 3. And f is the half of coefficient of y, which is a 5. So do you guess it, like how quick this can be? So, and I'm sure in your mark scheme, you will get the B mark, the independent mark for judging the center 3, and minus 5 should be the center of the circle. Well, you can check. Okay, so I've got a minus 2, a positive 1. Let's say here somewhere, minus 2 and positive 1, and a minus 2 and 11, and I'm sure it will be exactly underneath it. Since the x coordinate are same, this will be some vertical line over here. So let's read the question again. Find the area of the triangle formed by the tangents to the circle at P and Q. So there is, let me use a different pen. So there is a tangent over, let's say here, okay? And there is a tangent over, let's say here, right? Okay, I'm sorry about the drawing. Okay, so the tangents and these P and Q. So basically, I need to find area of this triangle. Okay, so obviously, you might have figured it out already that I need to find the equation of tangents, solve them simultaneously, find the point of intersection, and then go for the triangle area. So I'll be needing more space. So let's do it on the next page. Okay. So now we do the next part of the question. And if you have lost it, like you've lost track of what we were doing, we were trying to find the intersection point of the tangents because we wish to find the area of the triangle formed by P, Q, and this intersection point of the tangents, right? So first I connect this line from center, let's call this C, to this tangent point P. And this is perpendicular. You've learned this property in your IGCSE. Radius is perpendicular to tangent. Let's get the gradient. M of PC. That's going to be y2 minus y1 divided by x2 minus x1, which is, okay, yeah, that's going to be a negative 6 over a 5. So if I call this tangent 1, let's call this 1. So the gradient of tangent 1 then will be the negative reciprocal of this perpendicular lines. I've got a point P and I've got the gradient. Let's find the equation quickly. Y minus y1 equals to m x minus x1. In these lengthy calculations, you gotta go slow. You gotta be careful because even I can do mistakes. Like sometime if I try to write too quickly, I can just, do some blunder with the signs and stuff. So be careful, go slow, and, practice can make things great for you. 5 over 6 x plus, this will be a 10 over a 6 plus 1. Okay, so y is going to be a 5 over 6x plus 16 over a 6. So that's my first equation. Let's box this one. Okay. And next, I connect Q with C, and this is also perpendicular, tangent, and radius. Let's get the gradient of QC. This will be y2 minus y1 over x2 minus x1, which is a 6 divide 5. And if I call this 2, the gradient of tangent 2 is going to be a negative 5 over 6. Let's find the equation y minus y1 equals to m and x minus x1. Well, you can use a point slope form or slope intercept form. Both can work. It's up to you. So that will be a minus 5 over 6x minus 10 over 6 and minus 11. Okay, so you can use calculator for these calculations. This will be minus 10 minus 66 minus 76 divide 6. Okay. Okay, so now I solve them simultaneously, which means I need to equate these lines. 5x plus 16 over 6 equals to minus 5x. I'm expressing them as single denominator. I can get rid of the 6. 10x will be 76, 86, and 6, negative 92. Okay? Okay, so negative 92 over a 10. I can keep it this way or maybe 246 over 5. So x is a negative 46 over a 5. I need to find my y value now. Let's box this one as well. Okay. I can use some calculator, right? 5 over a 6, too much calculations, huh? So minus 46 over a 5 and plus 16 over a 6, right? Oh, that's a negative 5. Negative 5. Oh, it means my diagram isn't that correct, but this is in the same horizontal line as the center, minus 5, and this is a minus 46 over a 5. Okay, so can we guess this point over here, this one? Can we guess this? I think you can easily. This is a minus 2 and a minus 5. Okay, now again, I ran out of space. I can use this part, but in your exam, make sure you know that you have to write within the given lines. So there are extra sheets, extra pages given for each question. So this is a P, which is a minus 2 and 1. You got to be careful with these coordinates. And Q, which is a minus 2 and minus 11. Okay, so I need this thing, which is the perpendicular height. So this is easy to calculate. The base of the triangle can straight away be 12, right? Because it's just the difference of the vertical coordinate. So this is a minus 2 and that's a 46. So if you do minus 2 minus a minus 46, that's just going to be a 46 over 5 minus a 2, which is a 36 over a 5. That was easy, right? But still, if you are confused with this, you can go with the distance formula, do like a couple of more steps and then you can reach distance. So area of triangle will be 1/2 into base into height, 36 over a 5. Okay, so I can just throw this in my calculator. So 36 times 12, that's a 432, and divide by 10. So that will be divided by 10. So my answer should be 43.2 unit square. I know it was a lengthy problem, but Make sure if you get confused, you can always rewind, check it again, try to solve these problems yourself. Walk this journey, and that's going to be a great practice. Okay, let's move on to the next problem. So this one I have picked from Summer 24-1-2, question 7. The equation of the circle is this time given in the standard form. Unlike the previous two questions that I solved, x minus 6 whole squared plus y plus a whole squared and equals to 18. Well, guys, you can always pause and go back and solve it yourself and come back and check my work later, right? So the equation of this thing, the line of the equation, this is tangent to the circle. So this is the line's equation, 2a minus x. Find the two possible values of constant a. Remember that circle is a quadratic expression as well, so you can apply the ideas you've learned in the chapter quadratics. You get my point, like discriminants and, all those things, inequalities. So, but this time I can just substitute the line into the given equation. So let's do that. This will be x minus 6 whole squared plus, in place of y, 2a minus x. So 2a and a will become a 3a minus x whole squared. But there's some work required. I cannot go with the idea of discriminant unless until my expression is fully simplified, expanded. So let's expand the expression. X squared minus 12x plus 36, right? Plus 9a squared minus 6ax and plus x squared. And subtract 18 as well. Okay? So this will be 2x squared. And there are two x terms, so let's subtract minus 6a plus 12x. Okay, I hope you got what I did. Just I factored out the x from the x terms. And this will be, okay, 36 minus 18. So that's going to be 18 equals to 0. Let's apply the discriminant now. It's standard now. So, oh, my bad. There is a plus 9a squared as well. This is going to be part of the constant term. Reason there is no x. Okay, I would have messed up. Okay, so I've got my a. Let's pinpoint the a's. A is 2, b is a negative 6a plus 12, and c is going to be 18 plus 9a squared. Let's apply the discriminant. So this is going to be b squared. Let's put a square minus 4a and c, 18 plus 9a squared. Okay, so this negative goes away. It's just going to be positive. So let's expand the rest. 36a squared plus 12 6 are 72. If you double 72, it's going to be 144a plus 144 minus 8 times 18 plus 9a squared, which is too much to handle, but we can use some calculator, right? Can we? So it's going to be 8 times 18, which is going to be, oh, that's a negative 144. That's good. Minus 72a squared equals to 0. This is a plus 144 and plus 144a and a 36a squared. Well, right, that's it. So this goes away. I have a minus 36a squared. Okay, and plus 144, a equals to 0. I can pull out the a, and that's going to be, I think I can pull out the 36 as well. So divide 36, that's going to be 4. So minus 36a, if I pull this out, factor this out, it's going to be positive a minus, how much was that? That's going to be 4, right? Equals to 0. So that gives me minus 36a equals to 0, or a minus 4 equals to 0. So my answers for a are a 0. Either a can be 0 or a can be a positive 4. Well, both of them work because they were asking for two possible values of a, and I solved this quadratic equation to get two possible values. Let's look at the b part of this problem. So this is part B of the same question. Find the two possible equations of the circle. Which circle? The only information we have from the previous part is that the circle's radius is 10. Okay? And we proved, you can rewind and check again, we proved that the center passes through this line, 1/2 x minus 4. So I'm going to recreate this circle. This was something like this. And the center, I don't know. All I knew was there was a chord. A, which was a 4, 3, and B, which was a 8 and a -5. Okay, so we have this line. Obviously, this passes through the center. So now we are looking for the possibilities. My radius is fixed, but obviously I need two possible kind of centers. So a clever way of solving this problem is that you can suppose that if, let's say, the x coordinate of the center is k, I'm just choosing an alphabet, the y coordinate, since it lies on the line half x minus 4, so you can say this will be k over 2 minus 4, right? You can suppose if you suppose A to be the center of the circle, your y coordinate of the center of the circle is going to be A over 2 minus 4. Uh, It's up to you. You want to use A or K. I'm using K, right? Okay, now I will write the standard equation of circle using this center. So x minus k squared plus y minus k over 2. And okay, let's just keep it in the bracket. This is the y coordinate of the center. Squared and equals to 10 squared, right? So now this is the part which is cool. Like I know I can't solve this equation. There are so many unknown, but I can substitute any of the given point, whether this or this. It's up to you. You want to put A or B. I'm going to put in B, let's say. So x coordinate is 8 minus k squared plus this will be minus 5 minus k over 2 plus 4. So this will help me get a quadratic equation in k, which you'll see how I'll solve that one. 8 minus k squared plus this is going to be a -1 negative k over 2 squared. Now know your expansions. Algebra, you can expand a double bracket. If you want to go with the identity, you can solve that. So I like to go with the identity 64 minus 16k plus k squared. And this, well, you can check it. 1 plus k squared over 4. And that is 100. Okay. So this will be a 5 over 4k squared minus 15k. So this is a 64 and plus that's a 65. So minus 100. That's going to be 65 and minus 35 equals to 0. I know I can get rid of this 5. This is going to be k squared over 4 minus 3k and minus 7 and equals to 0. This goes away. If you time the whole equation by 4, I'm just trying to simplify it so I can factorize it easily. You can use a quadratic formula as well. This is going to be 12k minus 28 and equals to 0. Okay. Okay, and that is a factorizable equation, 14k plus 2k. It's not necessary that it's a factorizable equation. Sometime you might get an unfactorizable one which you can solve using a quadratic formula, k plus 2 equals to 0. So one of the possibilities is 14, the other one is a minus 2. Let's get our two possible centers. When k is a 14, your center will look like 14. And 14 divided 2 is a 7, minus 2, that's a 3. So one of the possible equation of circle is going to be x minus 14 squared plus a y minus 3 squared and equals to a 100, right? Let's just box this. Okay, ran out of space again, guys. So when, let's say k is a minus 2. Make sure, again, disclaimer, don't write in the blank spaces on your exam. Always write on the like the dotted lines because that's the part that's going to be scanned and the examiner can take a look at that. So k minus 2, this will be a minus 2 and minus 2 divided by 2 is a minus 1, so -5. So the other possibility is going to be x plus 2 squared plus a y plus 5 squared and equals to a 100. So that was a good one. Okay, creative problem. We had to find two possibilities. Make sure you rewind, go over these questions again, spend some time, and you'll be master of this topic, right? Let's look at the next problem. So this one I have picked from Summer 24 1-2, question 7. The equation of the circle is this time given in the standard form. Unlike the previous two questions that I solved, x minus 6 whole squared plus y plus a whole squared and equals to 18. Well, guys, you can always pause and go back and solve it yourself and come back and check my work later, right? So the equation of they're saying the line of the equation, this is tangent to the circle. So this is the line's equation, 2a minus x. Find the two possible values of constant a. Remember that circle is a quadratic expression as well. So you can apply the ideas you've learned in the chapter quadratics. You get my point, like discriminants and, all those things, inequalities. So, but this time I can just substitute the line into the given equation. So let's do that. This will be x minus 6 whole squared plus, in place of y, 2a minus x. So 2a and a will become a 3a minus x whole squared. But there's some work required. I cannot go with the idea of discriminant unless until my expression is fully simplified, expanded. So let's expand the expression. X squared minus 12x plus 36, right? Plus 9a squared minus 6ax and plus x squared. And subtract 18 as well. Okay? So this will be 2x squared. And there are two x terms, so let's subtract minus 6a plus 12x. Okay, I hope you got what I did. Just I factored out the x from the x terms. And this will be, okay, 36 minus 18. So that's going to be 18 equals to 0. Let's apply the discriminant now. It's standard now. So, oh, my bad. There is a plus 9a squared as well. This is going to be part of the constant term. Reason there is no x. Okay, I would have messed up. Okay, so I've got my a. Let's pinpoint the a's. A is 2, b is a negative 6a plus 12, and c is going to be 18 plus 9a squared. Let's apply the discriminant. So this is going to be b squared. Let's put a square minus 4a and c, 18 plus 9a squared. Okay, so this negative goes away. It's just going to be positive. So let's expand the rest. 36a squared plus 12 6 are 72. If you double 72, it's going to be 144a plus 144 minus 8 times 18 plus 9a squared, which is too much to handle, but we can use some calculator, right? Can we? So it's going to be 8 times 18, which is going to be, oh, that's a negative 144. That's good. Minus 72a squared equals to 0. This is a plus 144 and plus 144a and a 36a squared. Well, right, that's it. So this goes away. I have a minus 36a squared. Okay, and plus 144, a equals to 0. I can pull out the a, and that's going to be, I think I can pull out the 36 as well. So divide 36, that's going to be 4. So minus 36a, if I pull this out, factor this out, it's going to be positive a minus, how much was that? That's going to be 4, right? Equals to 0. So that gives me minus 36a equals to 0, or a minus 4 equals to 0. So my answers for a are a 0. Either a can be 0 or a can be a positive 4. Well, both of them work because they were asking for two possible values of a, and I solved this quadratic equation to get two possible values. Let's look at the b part of this problem. So let's take a look at part b. For the greater value of a, find the equation of diameter which is perpendicular to the given tangent. Okay, so we know that the equation of circle was x minus 6 squared plus y plus a squared equals to 18. And the two values that I found for a in my previous part was a equals to 0 and a equals to 4. So I need this 4, not this one. So this is the one which I need for this part for the greater value of a. So let's just erase this part and replace it with 4. Okay. So they are saying which is perpendicular to the given tangent. The tangent was given as y equals to 2a minus x. So if I substitute x to be 4 at a equals to 4, the equation will now look like 8 minus x, right? So let's just sketch the circle. It will look like 6 and minus 4. Okay. And I've got the equation of tangent here. It has a negative gradient and a positive 8 y-intercept. So I believe it will look like this. Okay. So I need the equation of the diameter. That's the thing I need, which is perpendicular to the tangent. So tangent's gradient is a -1. So diameter's gradient is going to be a +1, right? And I can use the center of the circle to find the equation. Remember, tangent and radius are perpendicular, right? So y minus y1 equals to m, and x minus x1. This will give me y equals to x minus 6 minus 4, which is y equals to x minus 10. And that is the required answer. Okay, for the last question, I have picked Winter 24, paper 1-1, question 6. We have two circles now. Circle C1 and C2 have equations this and this. One of them is in the standard form, the other one is in the expanded form. So the question says find the distance between the centers of circles. So for this expanded circle, I told you like you can go with the completing the square as well, or maybe you can go with the shortcut method. I did the shortcut method earlier, so I'm going to be performing the completing the square this time. So you can have an idea about that as well. But this is, remember, this is part of the quadratic syllabus, and elsewhere, like sometime you need in functions when you need to find inverse of a quadratic function. So completing the square is should be in your toolkit as well. Okay, so this will be x squared plus 6x plus 3 squared minus 3 squared, and plus y squared minus 10y plus 5 squared minus 5 squared, and plus 18 equals to 0. This will be x plus 3 squared. Looks lengthy, but works well. X minus 5 squared and minus 25 plus 18 equals to 0. This will be x plus 3 squared and plus y minus 5 squared. Could have been much quicker with the shortcut, but let's see. Okay, this is 25 and 9. That's gonna be 34. So I need to subtract, or I can do the other way around, minus. Oh, that's gonna be 16, right? Okay. So the center is minus 3, 5. And I don't need the radius, but I'm just sharing the radius is gonna be 4. Okay. What about the second circle? This is pretty easy, straightforward. So for this circle, this is C1. Okay. For C2, we can just write the center, that is 9 and minus 4. Okay. And the radius is 8, since 64 to the other side is 8 squared. I need the distance between the centers. So minus 3 minus 9 whole squared plus 5 plus 4 whole squared, which is going to be a -12 squared plus a 9 squared, and that's going to be 144 plus 81. Okay, and that is a 225. Oh, that's a perfect square. So 15 is your answer, right? Distance between the centers. Let's take a look at the part B. So P and Q are points on C1 and C2, respectively, some random points. The distance between P and Q is denoted by D. Find the greatest and the least possible values of D. So I need my circle 1, which is x plus 3 squared plus y minus 5 squared, and equals to 16, which can be written as 4 squared. And C2, on the other hand, is x minus 9 squared plus y plus 4 squared from the previous part, and equals to 8 squared, right? So it's just a 3-mark question, but still, do you have a curiosity to think like, do they overlap these circles? I'm just gonna sketch like this is a circle which is a -3 and a 5, and its radius is 4. Let's say if this is a 4. Okay, so -3 and 5. I can make the x-axis like this, just trying to investigate. So -3, it should be something like this, right? Y and x. It's just a sketch, remember, not an accurate drawing. So 9 and a -4 here somewhere, and the radius is 8, right? So this one is a big one, right? Like this. Okay, so you get the idea. So they don't overlap, obviously. The center doesn't look in the right place, but still. Wait, I can make it 9 and a -4, right? 900 minus 4. Radius is 8. So now I can clearly visualize that their distance between the centers was already done, 15. For the minimum distance, you need this thing. This is the D minimum. Okay. And this whole thing is going to be the distance maximum, right? You can read the question again. What's the minimum possible distance and the maximum? So if the C1 and C2 are here somewhere, like these points, so the distance minimum is going to be just take your distance 15 and subtract the two radii, which is 4 and 8. So 15 minus 12 is going to be 3. And distance, the maximum possible distance, you get it. Like you will add the radii this time. So this is 15 plus 12, which is 27. And so that wraps up our deep dive into equations of circles. If you have followed through, you now have the tools to handle any circle question that appears in your A-level exam. Keep practicing, keep exploring, and you'll see how every equation starts to tell its own geometric story. So, this is Global Math Mentor, over and out.